This is MCA practice problems 31 to 35. Number 31 says use a diagram below to answer the question 31. An engineer models a bridge crossing a riverbank using two parallel lines to represent the riverbanks and two parallel lines to represent the bridge in the aerial view. The bridge is not perpendicular to the riverbanks, so which of the following statements about the angles formed between the bridge and the riverbanks must be true? It's important to read this one all the way through. Now we know these two lines are parallel, these two lines are parallel, and nothing is perpendicular, meaning they create 90-degree angles. Otherwise, everything would be 90 degrees. So what I'm going to do is I'm going to go back and I'm going to redraw this. I'm going to redraw this using two parallel lines cut by a transversal. These two lines for the bridge can just overlap. One just shifts over onto the other, and it's easier maybe to see if I redraw it. 1, 2, 3, 4, 5, 6, 7, 8. And let's go through all the possibilities that they give us. Let's first look at A. Angle 5 is congruent to angle 3. Is that true? Are they equal? Angle 5 is right here. It's obtuse. It's greater than 90 degrees. Angle 3 is acute. It's less than 90. Those are what we call same side interior, and they are supplementary, meaning they add to 180. They are not congruent. It takes out A. How about B? Is angle 1 congruent to angle 2? Angle 1 is here. That's obtuse. Angle 2 is here, and that one is acute. Again, those two are not going to be congruent. One is less than 90, one is greater than 90. So those two are not congruent. How about 2 and 8? 2 and 8 leaves us with this angle and this angle. Angle 2 is acute, less than 90. Angle 8 is obtuse, it's greater than 90. So again, 2 and 8 can't be congruent. That leaves you with D. Let's verify D is true. Is angle 1 congruent to angle 8? Angle 1, again, is obtuse. Angle 8 was obtuse. So very strong possibility. Let's just, in fact, that is our answer, but let's just verify how that's possible. Angle 1 is congruent to angle 4 because these two angles are corresponding, vertical angles, and vertical angles are congruent. Then what about angle 4 and angle 8? Those two are both obtuse, but more importantly, they are what we call corresponding angles. So those two are congruent. So angle 4 is, angle 4 and 8 are congruent. Angle 1 and 4 is congruent. That means angle 1 is congruent to angle 8. So D is our best answer for 31. Let's look at 32. Use a diagram below to answer the question. Jeremy is the set designer for the school play. The center of the circular stage he is designing is point P. Walls of the set are represented by segment PS, segment PT, segment RS, and segment RT. Using the angle and arc measurements in the diagram, what is the measure in degrees of angle RTP? Let's walk through this. Angle RTP, what they want is angle RTP. They want to know what is this angle right here. How big is that angle? Let's go through. First thing it's easiest to do is label everything you know. And in this scenario, we know that this angle is going to be 21 degrees as well. Why? Because you have an isosceles triangle. Segment PT is a radius and segment PS is a radius, and radii are equal. So those two sides are equal, which means angle S and angle T, or this angle here and this angle here, are going to be both 21 degrees because it's an isosceles triangle. Great, so that gives us part of that, and now it would be really nice to know what angle RTP is since that's what they're asking. Let's look at the big angle, RTS. Because it cuts off an arc of 76 degrees, this full angle here is going to be half of whatever the cutoff arc is, which is 76 degrees. And half of 36 degrees, or 76 degrees, is 38. Well, this whole thing is 38 degrees, and this angle here is 21. I'm left with, in this space right here, 38 minus the 21 for a total of 17 degrees. So A in this scenario is going to be our best answer. Let's look at question number 33. Find the area of the figure using 3.14 for pi. 67.71, they give you your different possibilities. And I look up here and I see a rectangle, but one of the corners is kind of thrown off. So what I like to do is I like to break this into parts, into different types of shapes. And it looks like I actually have 3 different shapes here. This shape is 9 by 6, and it's a rectangle, and the rectangle is base times height, or 54. This is a square. If this whole thing is 12 feet, and this was 9, that leaves us with 3 for this distance. So if this is 3, this is 3, this is going to be 3 by 3, or 9 square feet. So right now I have 54 plus 9 square feet. The question is, what is this distance or this area right here? Well, if you notice, that is actually a quarter of a circle. So let's go through and find the area of a circle. The area of a circle is equal to pi times the radius squared, and the pi times the radius in this case is 3, this number right here. So this radius squared, which gives us 9 pi, or pi times 9, multiply that on your calculator and you get 28.27. But that's for the area of the full circle. I'm only interested in a fourth of the circle, so I'm going to take 1/4 of the 28.27. And at that point, I get 7.07 when you take 1/4 of 28. So this area right in here is 7.07. So I can go ahead and add that to the 9 and to the 54. So plus 7.07, and that'll give us our answer of 70.07 square feet, which means B is our best answer for question number 33. Number 34. Elena inherited 3 small spherical gold beads from her grandmother. They had radii of 2 millimeters, 3 millimeters, and 3 millimeters. She wanted to have them melted and recast to form one larger sphere. Its radius would be closest to what is the question? Well, in this case, the volume of a sphere is going to be 4/3 times pi times the radius cubed. So let's go through and figure out. She has 3 of them, a 2 millimeter, 3 millimeter, and a 4 millimeter. And she wants to melt those down. So let's figure out the volume of each one individually. So 4/3 times pi times 2 cubed. I want to find out. I need to find the volume of 4/3 times pi times 3 cubed. I also need to find 4/3 times pi times 4 cubed. This 2 went here, this 3 went here, and this 4, as you can guess, went there. Let's find these 3 answers using our calculator. Easiest way is to do this in parentheses. 4 divided by 3, close your parentheses, times pi, which is second, the caret key, the number right above that is pi, times, and let's do the first one, 2 to the 3rd power. Well, the 3rd power, if you look under math, number 3 is the cubed power. So I hit cubed power to the 3rd, I hit enter, and we get 33.51. So this one would be 33.51. You'd go through and do the same thing for the other ones. You'd find that this is 113.10. And this one is 268.08. Well, those get melted down and combined. In other words, I need to add those up. It gives me a total area of total volume of 414.69. But she wants to cast one larger one. So I've got to take this volume that I can work with here, this 414, and go back and work with the equation. The volume is equal to 4/3 times pi times r cubed. Well, right now, I know this is the volume I have to work with. So 414.69 is equal to 4/3 times pi times the radius cubed. So I need to somehow solve for the radius. That's what they're asking about. So I need to get rid of this 4/3 and this pi. These two numbers I need to get rid of. And since it's all times, we can go ahead and divide by 4/3 pi. And whatever you do to one side, do to the other. So I'm going to divide by 4/3 pi on my calculator. Those cancel out. Leaves me with r cubed is equal to, and if you do that on your calculator, you get 99. So 414.69 divided by 4/3 pi is 99. Now 99 is equal to r cubed. So I still need to find the cubed root. In other words, I need not the square root, but the cubed root. What multiplied by itself 3 times gives me 99? So how do we find the cubed root? Let's go through and do this on our calculator again. I can show you how to do that. So here's our calculator. We want to find the cube root. So go back, hit math. Cube root is number 4 here. So I hit 4, cube root of 99. Hit enter. And our answer is 4.63. So R is equal to 4.63. And we need to find the answer that is closest to. And that would be B as in boy, 5 millimeters. 35. At a certain time of the day, the length of the shadow of the Eiffel Tower to the center of its base was 225 meters, when the sun's angle of elevation was 55 degrees. What is the approximate height of the Eiffel Tower? So they are asking us to find, is this distance right here? What is the height? And we know that that's going to be perpendicular to base. They actually showed us that. This angle is 53 degrees, so we are dealing with a right triangle. That's 225 meters. In this case, I can't use the Pythagorean theorem because I only know one of the sides. I don't know the other two. So this comes into play, and we end up using what we call SOHCAHTOA, which is sine of an angle is opposite over the hypotenuse. The cosine of an angle is the adjacent over the hypotenuse. And the tangent of an angle is opposite over adjacent. Well, if I'm looking to find the height, I know I have 225 and the angle of 53 degrees. I'm trying to find the height, and I have the 225. I do not have the longest side, which is the hypotenuse. We're not dealing with that. So I go back to this. Sine is opposite over hypotenuse, so cosine is opposite over hypotenuse. I'm not dealing with the hypotenuse, so I don't have to worry about either one of those. That leaves us with the tangent. So the tangent of the angle, which is 53 degrees, is equal to the opposite over the adjacent. So I'm going to go opposite is h for height over the adjacent, which was the 225. Now do your algebra. Multiply both sides by 225. That cancels that out. Whatever you do to one side, do to the other. Tan of 53, they gave us a little key here, so I can just fill that in. 225 times the 1.3270 is equal to the height. So my height in this case ends up being 298.6, which gives me an answer of C. What if they don't give us this box right here? Then you have to use your calculator. I just want to review how to use your calculator real quick to find the tangent of 53. So what you'll do is you'll go to your calculator, and it's not a bad idea to everybody have this set up anyways. First thing you want to do is go to mode and realize we are working with degree mode. So you need to go down to radian, just go down a couple. Go over to degree, not radian. While it's blinking, you hit enter. Now you're in degree mode, so if you look back down, notice it's blackened in, so we're dealing with degree mode. All right, now you can hit second quit. Clear out of that. I want to find the tan of 53. I just hit tan 53 and hit equals. And there's your 1.3270. So if they don't give you the key, and I would suggest going into your test, right off the bat, everybody should do mode and make sure you are in degree mode. That is probably the default that we're going to want to work with. That works on 31 to 35. Hope that helped.